Today, we're going to talk about the unwritten rules of the universe, and more importantly, about the one person who dared to challenge not just the cosmos, but his own fate. It's an incredible story.
I mean, think about it for a second. We all live by certain physical rules, right? Gravity is what keeps our feet on the ground. Thermodynamics means your morning coffee is definitely going to get cold if you forget about it. These laws are just how things work, but are they the only rules?
Well, back in 1971, a young physicist came along and proposed a brand new one, a rule so fundamental it would completely change how we think about the most bizarre objects in the entire cosmos. But to really get a handle on this new law, you first have to understand the extraordinary mind that came up with it.
And our story doesn't start out in some distant galaxy. Nope, it starts in wartime England with a kid who just couldn't stop looking up at the stars.
So, Stephen Hawking was born in Oxford in 1942. And here's the thing, he wasn't some kind of movie-style child prodigy. His teachers actually thought his work was pretty messy. But what he did have was this deep, relentless curiosity about how things were put together, how they were wired. And that led to his first quiet act of rebellion, choosing to study cosmology, the universe itself, instead of medicine, like his dad wanted. His path was set. He was heading to Cambridge.
And Cambridge. Oh, it was the perfect playground for a mind that loved pushing ideas to their absolute breaking point. But then, just as his intellect was really taking flight, his own body began to fail him.
You know, it all started pretty subtly. In his early 20s, he found himself tripping more, his speech would slur a little, things you or I might just brush off. He tried to ignore it, but after a whole series of hospital tests, the verdict came down and it was devastatingly simple. Motor neuron disease, ALS. A disease that just relentlessly attacks the nerves that tell your muscles what to do. And the prognosis was just brutal. The doctors told him he had 2 years left, maybe 3 if he was lucky. So, what do you do? I mean, really, what do you do with news like that? For a while, he just retreated. And who could blame him? Why bother trying to solve the universe's biggest puzzles when your own clock is ticking down so fast? But then something shifted. The turning point really came from 2 places: love and this fierce intellectual defiance. His relationship with Jane Wilde gave him something concrete to live for, and the academic fire at Cambridge made him realize something profound. He basically made a choice. If his physical world was going to shrink, then his mental world was going to have to expand without any limits at all.
And oh, did it expand. Fired up with this incredible new sense of urgency, he poured everything he had into his research, and he came up with his first huge scientific win. Okay, so to get what he did, you've got to understand something called the event horizon. Just think of it as the ultimate one-way street of the universe. It's the edge of a black hole, the absolute point of no return. You cross that line, and there is no coming back.
So in 1971, Hawking puts forth this idea that sounds simple, but is actually mind-bendingly profound. He said, the total horizon area in black holes can never go down. He proved that the surface area of that point of no return can only ever get bigger or stay the same. It became known as the area theorem.
Let's picture it. You've got 2 black holes spiraling toward each other. When they finally crash and merge into one giant black hole, the surface area of that new event horizon is always bigger than the 2 original areas added together. It's like a fundamental rule of cosmic accounting. But Hawking? He was just getting warmed up. He was about to come up with his most revolutionary idea ever, and the crazy part is, it seemed to completely contradict the very rule he had just established. See, for the longest time, everyone thought of black holes as perfect cosmic prisons, a one-way door. Anything that goes in is gone forever. But in 1974, Hawking drops an absolute bombshell. He says, actually, black holes aren't completely black. They have a temperature, they glow, and they are very, very slowly leaking energy back out into space.
And this phenomenon, this leak, got a name: Hawking radiation. An idea that completely revolutionized theoretical physics, but how on earth does that even work?
All right, here's a way to wrap your head around it. Think about a radioactive atom. It's unstable, right? So every now and then it just spits out a little particle. Well, Hawking figured out that the insane gravity right at the edge of a black hole's event horizon does something kind of similar. It essentially forces the black hole to emit particles. And what does that mean? It means a black hole can shrink, and over unimaginable amounts of time, it can actually evaporate completely.
So, Hawking had laid down these incredible laws for black holes on paper, but proving them with actual observation,
Well, that was a whole different story. That would take decades, and a machine that could literally listen to the echoes of the cosmos itself.
50 years. Can you imagine? For an entire half-century, his area theorem was this beautiful, foundational idea in physics. But it was still just a theory. No one had ever actually seen it happen.
And then, 2015, everything changed. This incredible observatory called LIGO, which is basically a giant set of ears for listening to the universe, finally detected ripples in the fabric of space-time itself, gravitational waves.
And that very first signal they picked up, it was the perfect cosmic test. It was the sound of two black holes, a billion light years away, in a final, frantic dance before merging into one. For the first time ever, physicists could actually measure the before and the after. So the big question, the 50-year-old question was, did it obey Hawking's law?
And the answer, confirmed with 95% confidence, was a resounding yes. The total event horizon area got bigger. It did not decrease. 50 years after he conceived it on paper, the universe itself confirmed he was right. It was this triumphant, incredible echo of his genius, finally heard across the cosmos.
You know, Hawking's legacy is so much bigger than just his mind-blowing equations. It's in his absolute determination to share the wonder of it all with the rest of us. His books took these impossibly complex ideas about the universe and made them accessible, exciting, and understandable for millions of people. He invited everyone to the party.
Which leaves us with one final powerful thought. Stephen Hawking was told his time was up. He was living on borrowed time, and with that time, he redefined our understanding of the entire universe. It just forces us to ask ourselves, if a mind so profoundly constrained can reach so far, what are the real limits on our own potential?